So what we tried to do in the study is design a program for children like that, children in India living in the poorest sections where they now will be attending school because school is compulsory now, but where their parents did not, and see if we can develop activities that they can play in relatively informal preschool classrooms in groups that will give them the kind of preparation they're going to need to succeed in school the following year when it begins.
So I've been working on primary education on and off for about 15 to 20 years in developing countries, in India, in Kenya in particular. And one thing that we have consistently found is that key problems that children face when they reach the middle of primary schools is that the curriculum is such that teachers are compelled to teach to the top of the classrooms because the curriculums are very demanding, and they are not particularly interested in teaching any of the children who have reached grade 2 or grade 3 or grade 4 without the knowledge that places them at the top of the pack. And as a result, what happens very quickly in primary school is kids get lost, they stop paying attention, they get promoted from class to class, and they reach the end of primary school with essentially very little knowledge. Well, if we could take the poorest kids and instead of sending them to school with a slight gap because they haven't been to preschool or they haven't been to very good preschools or their parents are not able to help them out in their schoolwork, why couldn't we try to use the best of cognitive science available and bring them to school with a slight advantage, with a slight leg up?
So let me make a confession. In my life, it never occurred to me that I would ever end up collaborating with an economist, or for that matter, doing an experiment that actually could eventually make a difference in the real world. But Esther Duflo, of whom I'd been a fan for a very long time, challenged me with an opportunity that I couldn't turn down. She pointed out relatively tactfully that although I had spent a lot of time trying to figure out what children know at different times, what knowledge develops before what other knowledge, what conditions we can use in laboratory experiments to move children's knowledge along, the real thing that we want to understand is how knowledge grows in people in the real world. And for young children, that means grows spontaneously in homes and in preschool classrooms. And the opportunity that she provided was to look at this question, bringing to bear all the rigor that we use for our research in the laboratory, yet focused on a situation in the real world where we could do a real experiment, a randomized control experiment, to evaluate the impact of interventions informed by basic research in cognitive science on young children's development.
So this curriculum was targeting children between the ages of 4 and 5 years. And we designed 2 different sets of games for kids to play. The main intervention was a set of math games where kids were encouraged to exercise their intuitive abilities in number and geometry. So in particular, skills that allow them to estimate the relative number of dots, large numbers of dots, and compare those numbers to sort cards. So there'd be a large number of red dots on one side of a card, a large number of blue dots on the other side of a card, and kids would have to sort the card by the color of the more numerous dot array. So this was a game that was meant to be played by small groups of children in pairs or slightly larger groups, and it was supposed to be fun, fast-paced, and social. So kids could interact over these cards and have maybe little competitions or cooperative play. So these were all the kinds of skills that emerge really early in human development, sensitivity to intuitive number and geometry, that the games were targeting in a social context that were meant to be fun and encourage sort of desire to play together and desire to engage in these kinds of skills. We also made a group of games for the active control condition. So the target treatment was these math games, but we also made games that had the same rules and structure as the math games, but targeted different content. These games targeted content in the social domain. So instead of exercising kids' intuitive skills for number and geometry, they exercised kids' intuitive skills in the social domain. For example, their ability to follow another individual's gaze or read their emotional expression.
Immediately after the end of the intervention, we found that children who had played the math games had significant improvements in their intuitive concepts of mathematics, both geometry and number comparisons. They also showed some improvement even in symbolic skills, such as recognizing numbers and things like that. The children who had been part of the games which have the same rules but engage social skills instead showed improvement in social skills but not in mathematics. So that could tell us that this was really about the content of the games, not the fact that there is an adult playing games with them with these rules. Several months later, what we found is that the gain in intuitive mathematics were very persistent. However, all the symbolic games had gone.
We learned what in a sense is we learned there's one thing that's quite similar, I think, about field experiments and laboratory research, although many things are different. The great blessing of doing experiments is you learn when you were wrong. You learn when your ideas were too limited. You learn when there were important factors that you failed to take account of. And I think in this experiment, we learned a couple of things that were strongly positive. And one thing that really provided us with a guide, I think, for future work, where I think basic thinking in cognitive science maybe was not broad enough. The positive things that we learned are, first of all, the research that we do in rarefied laboratories, mostly with children living in well-educated families and so forth, actually can uncover basic processes that operate all over the world. The kinds of activities that we developed for children in India are just the kinds of activities that excite children in Cambridge, Massachusetts, right? We really were able to take the fruits of our experience with research in the lab and develop games that were effective at engaging kids, at getting them to learn things, and in fact remained effective a full year later. After games were taken away, children still were showing benefits from the games that we had developed for them. I think the most important thing that we learned is that the work that we've done in the laboratory is not sufficient to establish what actually causes knowledge to grow in the mind of a child over time spans of years in the environments in which children live and learn.